So when we take the terms of a sequence and add them together, we call that a series. A series is that sum that's written out for us. And a series could be finite, has a fixed number of terms. It could be infinite. It could be a sequence that continues indefinitely. So to begin our study of series, let's first start by writing the expression for the general term of this sequence. So if you look at the sequence, it goes from 5 to 8 to 11. It looks like it's going up by adding 3 each time. So that's an arithmetic sequence. So I know an arithmetic sequence is going to start at 5. And then because it goes up by 3, the first term is 3 times 0, or 5 plus 3 times 0. The next term is 5 plus 3 times 1, and you might remember this from yesterday's work. That would eventually lead us to a pattern that would look like 5 plus 3 times n minus 1. And if you want to kind of distribute it through, we can. We get 5 plus 3n minus 3. Combining some like terms gives us a 3n plus 2. Just another way to express that general term of this sequence. So what I'd like to do now is show you a way to represent that series. And the way we're going to represent it is we're going to represent it using sigma notation. Sigma is a way that we use to represent a series. This is the Greek letter sigma. We usually use its capital form. And let's talk about the different parts of that representation. First, what you'll notice is that the variable is n here. N is what we call the index. It doesn't have to be n. Typically, I is used, but it could be any variable you want. 1 is the lower limit. So that means I'm going to take the first term of the sequence. 4 is the upper limit. So I'm going to find the sum of terms 1, 2, 3, and 4 of my sequence. You don't have to start at 1. You can start at any value you want. And the final thing is the expression, 3n plus 2. That's the general term of the sequence. So let's practice that. Let's see if we can find the terms and then calculate the sum for this. So in this first example, I is equal to, or I starts at 3, that's our lower bound. Our upper bound is 5. So what this means is we're going to find the sum when I is equal to 3 of 3 squared minus 3. So I plug 3 in for my variable I. I'm going to add that to when I plug in 4. My lower bound is 3, and I'm going to 5. So the next term is 4 squared minus 4, substituting that 4 in. My upper bound is 5. 5 squared minus 5. And now I just need to find this sum. Well, the first set of parentheses, 9 minus 3 is 6. 16 minus 4 is 12. 25 minus 5 is 20. And when I add all those values up, 6 plus 12 is 18, plus 20. So that series is equal to 38. Just plugging in and finding the sum. And yes, we can use our graphing calculator to find this sum. I'm going to walk you through how to use the graphing calculator to find that next one. So the way we find our sum is we first go to menu, and then after menu, we're going to go to calculus. And in calculus, we want sum. And take a look at that. It just sets it up for us. So let me go back here for a second, and we'll do menu, and then 4, which was calculus. And then we choose sum. So that's the direction that we want to go in. Okay, we just need to type in these values. So I'll type in n down at the bottom, and n equals 1. And then from 1, we go to 10. And what we first want to do is the expression -1 to the n. Let's think about what that's going to do. -1 to the n. Because if n is an odd number, then we have the value -1. If n is a positive number, a negative number squared, or -1 squared, for example, is +1. So this is going to change the signs of the series. Pretend you have a sequence where one number is positive and the next number is negative and the next number is positive and the next number is negative. This is a situation how we would handle that. So it's negative 1 to the n, and then we're going to multiply that by 2n squared. So we want the sum of this. We press enter. Our sum is 110. So it's kind of expected that you'll use the graphing calculator to determine the sum, but the graphing calculator can't really let you write the sum or figure out what that sum is. So let's work a little bit on expressing a series in sigma notation. So if you want to try it on your own, you can. I'll take a look at this first one here. So right away I'm figuring, is it an arithmetic sequence or is it a geometric? Which way is it going? It looks like I'm going up by 6 each time. So I'm adding 6 to get to each term. So I've seen that before where my general term then is going to be 4 plus 6 times n minus 1. My starting value is 4, and I'm going up by 6 each time. Pretty good there. Do I want to simplify this? Yeah, you can if you want to. I'll simplify it down when I distribute. It's going to be 6n minus 2. So in my summation then, I want to go from n equals 1. My first term is 4. And I have 1, 2, 3, 4, 5 terms. So I'm going from 1 to 5. And my expression is 6n minus 2. So if I look at my second one, is it arithmetic? I don't think so, because then I'd add 3, but then I got to add 6. So yeah, this is not an arithmetic, this is a geometric one. It looks like I'm multiplying by 2. Well, I'm not really multiplying by 2, I'm kind of multiplying by a negative 2 because the sign changes each time. So what that's going to mean in my sum, I want to do this negative 1 to the n. And I'm going to do negative 1 to the n because if my first term is negative, I know when, for example, when n is equal to 1, negative 1 to the first power is negative 1. So negative 1 times whatever I put in there has to give me negative 3. So let's figure out what this general term now is. And I'm going to kind of ignore the negative for a minute because this negative 1 to the n takes care of my negative. So now I'm just thinking about 3 to 6 to 12 to 24. Well, if it's a geometric series, it's going to increase by 2. So I'm going to go 3 times 2 to the n minus 1 power. Let's just check that. When n equals 1, I get 3. When n equals 2, I get 3 times 2, which is 6. When n equals 3, 2 squared is 4. 3 times 4 is 12. So it looks like it's working out for me. So this is going to be negative 1 to the n times 3 times 2 to the n minus 1 power. And I'm only doing 4 terms, so I'm going from 1 to 4. So that's the idea on how to write a series in sigma notation.